Well, Math 8. Here we go. We've got lesson 3-3, linear and nonlinear functions. All right, so we're going to look and see what makes a linear function versus one that's not linear. So I've got two sets of coordinates here. I'm going to go ahead and plot them on the same graph. Let's start with the first one. -8, +8. That would be right about here-ish. So there's my first one. -6, 7. -6, 7. It's going to be right here-ish. Next one, -2, 5. Right here. 4, 2. 4, 2, right here. 10, -1. Right over here. All right, looking at those points, a linear function will make a straight line. Do those points look like they are in a straight line? Yeah, they look like they're in a straight line. So our first graph would represent a linear function because they make a straight line. So this is a linear function. Oh, is my pink dying on me? My pink pen is dying. Okay, I've got another pink pen. It's not my favorite pink pen, but it'll have to do. It's more fuchsia. Anywho, let's look at this next graph. So -4, 10. So -4, -10. There's my first point. Next one is -2, 2. No, -2, +2. There's that point. 0, 6. 1, 5. And 3, -3. Is that a linear function? No, not even close. So this one is definitely not linear because, look at that. It goes up, then it comes back down. So we have a nonlinear function. Nonlinear functions don't make lines, and that's definitely not a line. So linear functions will make lines when we graph them. Nonlinear functions will not make lines when we graph them if we connect all the points together. All right, so what we're going to do is we're going to find the rates of change for these functions. So let's start with this one. From here to here, that is a change of +2. From here to here, we're going up by 4. From here to here, we're going up by 6. And from here to here, we're also going up by 6. Okay, let's look at our y value changes. So from here to here, I am decreasing by 1. From here to here, I'm decreasing by 2. From here to here, I'm decreasing by 3. And from here to here, I'm also decreasing by 3. So let's look at these rates of change. Remember, the rate of change is like this, it's a slope. It's the same thing. So my rates of change for the linear function, -1 over 2. Let's do this next one. -2 over 4. Next one, -3 over 6. Last one, -3 over 6. So those are my rates of change. Those are actually all the same number. If you reduce -2 over 4, you get -1 over 2. If you reduce -3 over 6, you get -1 over 2. And this is also -1 over 2. So it doesn't matter which 2 points we picked, we get the same rate of change when we compare them, or the same slope. Now let's go ahead and look at the nonlinear functions. From here to here, we are increasing by 2. From here to here, we're also increasing by 2. From here to here, we're increasing by 1. And from here to here, we're increasing by 2 again. Over here, we're increasing by 12. 2 to 6, we're increasing by 4. 6 to 5, we're decreasing by 1. 5 to negative 3, we are decreasing by 5 to negative 8. Right. So looking at my rates of change, between these 2 points, the change in y over the change in x is 12 over 2. That reduces to 6. Between these 2 points, it's 4 over 2. The rate of change is 2. From these 2 points, we get negative 1 over 1. That's negative 1. From these 2 points, we get negative 8 over 2. That's negative 4. I never have the same rate of change. Over here, when we did a linear function, the rate of change was always negative 1/2. It all reduced down to the same number. When I reduced all of these, I got different numbers. That's how I know it's nonlinear. Linear functions, when you find your slopes or your rates of change, you're always going to reduce down to the same number. Whereas nonlinear functions, you won't always reduce to the same exact value. So we say that linear functions have a constant rate of change. Constant means it doesn't change. So its change is not to change at all. It's changing by the same amount. Negative 1/2, negative 1/2, negative 1/2, negative 1/2. Every time we checked it, it was changing at the same rate. Nonlinear functions do not always change at the same rate. All right. So let's identify of this group down here, which ones are linear functions and nonlinear functions. All right, here to here plus 2, here to here plus 4, here to here plus 4, here to here plus 4, here to here plus 8, here to here plus 8. All right, let's compare. 4 over 2. Let's do this one, 8 over 4. Change in y over the change in x, so we kind of have to flip it there. And then 8 over 4. What does this reduce to? 2. What does this reduce to? 2. What's this reduce to? 2. It reduces to the same amount each time. It reduces to 2. It's a constant rate of change. No matter what I do, no matter which points I pick, they all reduce to 2. Therefore, this is a linear function. Next one. From here to here, it goes up by 6. From here to here, up by 3. Here to here, up by 6. From here to here, we're going up by 2. Here to here, going up by 1. Yep. And here to here, we're going up by 2. All right, let's look at those rates of change. 2 over 6. Okay, 1 over 3. 2 over 6. What does 2 over 6 reduce to? 1 over 3. That means they all have the same constant rate of change. They're all reducing to the same value each time. So we increase by 6, increase by 2, 2 over 6, that's 1/3. Increase by 1, increase by 3, 1/3. Increase by 2, increase by 6, 1/3. Every single time, no matter which 2 points I picked, the rate of change was 1/3. This makes it linear. Next one. From 0 to 2, let's do this code. 0 to 2, that's an increase of 2. 2 to 4, increase of 2. 4 to 6, increase of 2. From 0 to 2, increase of 2. From 2 to 8, increase of 6. From 8 to 18, increase of 10. So let's look at the rates of change for this one. This one is 2 over 2. That's 1. This one is 6 over 2. That's 3. This one is 10 over 2. That's 5. The rates of change are 1, 3, and 5. Those are not constant. They're different each time. Therefore, this is not linear. It's something else. So this will not make a line. This is nonlinear. All right, last one. From -1 to 0, we're adding 1. From 0 to 1, we're adding 1. From 1 to 2, we're adding 1. From 1 to 0, we're subtracting 1. From 0 to 1, we're adding 1. From 1 to 4, we're adding 3. Rate of change, -1 over 1, which is -1. 1 over 1, which is +1. 3 over 1, which is 3. Different rate of change each time. This means it's not linear. This would be a nonlinear function. All right, Math 8, that's all I got for you. Math hard. See you guys later.